How you going, guys? Curtis from Cutting Edge Engineering. Today we're going to be continuing on with the rebuilding of our milling and drilling attachment. So if you missed part 1 where we disassembled it, there'll be a link in the description below. But today we're going to be making the new parts that we need. We're going to be making 2 new drive dogs, a drawbar and a handle for the quill feed. So we've got all of our materials. We're going to get started on making the drive dogs, and the material I'm using for that is a piece of 16mm key steel. So there was already one drive dog on the milling attachment. I don't know where the other one was, it got lost. But because we're going to the effort on this rebuild, I'm going to make 2 new drive dogs that are identical to each other, and I can put the other one in the cabinet as a spare. So we're going to get our key steel set up in the mill. So I generally don't leave parallels under any job when I'm using them in a vise, and the reason for that is they can vibrate loose, and if you are drilling directly through the part, you can come down and actually collide with them, ruining them. So I just take them out of the way and let the vise do its job, which is hanging onto that part. So I found center of the part, and we're just going to drill our holes for our mounting bolts. The drive dogs need to be at least 20mm wide, but because the key steel has been cut with a grinder, I'm going to give myself a little bit of extra room so it can be cleaned up with an end mill. So with our first hole center drilled, I'm going to move across 23mm and center drill the second one. Now I'm just going to use a 6mm drill to drill the holes all the way through. Now I'm going to change out to a 12mm end mill so I can counter bore a pocket for the head of the bolt. While that end mill's set up, I'm also going to machine the end of the key steel nice and true. And I have decided while I've got it set up, I'm going to chamfer the holes. Now with that done, we're going to cut them to length using a grinder. So these would work fine exactly the way they are, but I am going to set them back up and use an end mill to clean up those other 3 edges so they're identical. So that's both of our drive dogs completed. Now we're going to get on to making the new drawbar, and the piece of material I'm going to be using is a scrap piece of 35mm 4140 chrome bar. So I'm going to get that set up in the lathe. So because we need to machine the length of this drawbar from 35mm down to 17, and I don't have a following steady for this lathe, I'm going to do it in 2 setups, which is going to really help with rigidity. But first I'm going to face the end and center drill it. So I've got that set up for our first cut. I'm machining a length of 300mm. I'm going to run that at 635 RPM and a feed rate of 0.25mm per revolution. So I'm just going to start with a 2mm depth of cut and see how it goes. So that's machining really good. We're not going to change anything. So I'm just going to continue to rough this down till it's within 1mm of the finished size. So I got that first stage roughed down, definitely on the limit before we ran into vibration issues, but now we can bring it out the next 150mm and rough that down as well. So I've got that roughed down. Now I'm going to change out to my finishing insert, which is a TNGG. I'm going to take a very light cut across the entire length, and I'm going to lower the feed rate, and hopefully we don't get any vibration issues. So I've already run into vibration issues, and I'm not going to try and chase that because it's just going to be an ongoing battle. The overall diameter is going to fit down the spindle without too much drama, so I'm just going to clean up that area where I've joined the two cuts with a bit of emery tape so we can move on and not waste any time. So that turned out really good. I'm really happy with that surface finish. Next thing we're going to get onto is machining the thread on the end to hold the 40 taper tooling in the spindle. Before I thread it, I need to machine the end down to 16 mil to suit the M16 thread in the tooling. To thread it, I'm going to be using a Palbert full form insert. I'm going to lower the RPM and set the lead screw to a 2 mil thread pitch. So that's our thread cut and our tool fits on there perfectly. I'm just going to machine a chamfer on that edge and clean up that area where we had the vibration. Now we can flip the bar and turn down the other end, ready to mill the hex. First, I'm going to part off the excess material. Now I'm going to machine down the diameter to 25 mil, and that is to suit the outside diameter of the hex. And I'm going to use an S&MG neutral, and that is to give a chamfer at the base of the hex. And last thing I need to do is add a chamfer on the end. So that's all the lathe work completed. Now we can set this up in the mill. So there are a few different ways you can mill a hex, but for our setup today, the fastest method is to use a hex block in the vise. And to do the milling, I'll be using a 16mm 4-flute carbide end mill. Righto guys, so that's our drawbar completed, and that is 100% better than the piece of threaded rod they got from the hardware store. So now what we're going to do is get on to making the handle for the quill feed. And we're going to start with making the boss that goes on the side of the quill, and to make that we're going to be using an offcut of 75mm 4140. So the first thing to do is machine the OD to its finished diameter of 65mm, and we're going to go about 30 to 35mm in to give us enough clearance when we go to part this off. Next thing we're going to do is drill the ID using our 28mm twist drill. And we're going to bore it to its finish ID of 32.7mm using a boring bar with a TCMT insert. So now I'm just going to put a chamfer on the ID, and that'll be for a weld prep. And now I'm going to put a heavy chamfer on the ID, and that will be for where the handle gets screwed into. A little bit more. Now with that done, we can part this to length. So that's turned out really nice, but I still need to set it up the other way so I can do another weld prep on the ID. So now with that done, what we need to do is the hex on the ID to suit the hex on the end of the feed shaft for the quill. But because I don't have anything to slot or broach a 22mm hex, I'm going to be using a 22mm socket. For the sake of a $19 socket and a couple of minutes, that is our hex made. So now with that done, we can weld these together. And to weld it, I'm going to be using TIG. I'm going to be using an ER70S2 filler rod. I'll be backing that up with 100% argon, and I'm going to be using a Unimig 200 amp AC/DC machine. We're going to start at 80 amps and make adjustments as we go. So straight away I can tell it's not hot enough, so I am going to increase the amps. I prefer to start low and increase it if I need to, rather than start hot and blow a hole in it and make a mess. If you're wondering why I'm TIG welding this, that is because it offers a lot more precision and a lot more control on smaller parts, and it does create a very clean weld with very minimal cleanup. So I've got that welded. I'm pretty happy with how that turned out, considering I don't do TIG welding very often. Now what we can do is let that cool down and move on to making the handle.
Come on. Homeless. Homie, just stay. You're so silly.
To make the handle, we're going to be using a piece of 12mm 4140 chrome bar. All I need to do is machine and thread each end to be an M10 by 1.5. Before I thread this end, I am going to part it to length. So that's that done, nice, quick and easy. I am going to be fitting a Mugen shift knob to it. I do have a few of them floating around from back in the day, and you might have also seen them on various other machines in the workshop. So now the other part's cooled down, we can finish that off. So I'm just going to set this back up in the lathe so I can face and chamfer each side just to clean them up. So that's all of our lathe work completed. Now we're going to get it set up in the mill. So what we need to do is drill the hole for the spring-loaded detent, and what that's going to do is soft lock the boss onto the quill shaft so it doesn't fall off during operation. In order for the detent ball to work correctly, it has to be in the center of the flat on the inside of the hex. So in order to get that sitting parallel with the top of the vise, I'm going to be using parallels. Now that I've found center, before I drill it, I am going to go in with a center drill to create a good starting point because we're drilling on that corner. Now I can go in with my 6.5mm drill and drill that all the way through. Now I'm going to change out to an 8mm drill, and I'm going to take it very easy with that. I don't want to drill all the way through that hole, otherwise the ball will just fall out. See it work. So I'm really happy with that. That seats exactly where I want it to. Now I'm going to tap it to suit a 3/8 grub screw. So the last thing I need to do is drill and tap the hole for the handle, but because we need it on an angle, I'm going to have to tilt the head. So that's our boss completed. Now we can assemble the handle. So that's the handle completed, really happy with how that's turned out, but the real test is how it fits on the quill shaft. So that fits spot on, and there's just enough of that detemp ball engaging to keep that handle in place. So that's all of those parts completed. You'll have to stay tuned for part 3 where we continue with the rebuild. Thanks for watching. Today we're going to be continuing on with the rebuilding of our milling and drilling attachment.
If you missed.
If you missed it, so
Okay, you're gonna have to restart.
right, start again. Right, ready? Today we're going to be continuing on. Didn't even say the word. That happened too. So these work just fine the way they are, but I knew that was coming.
Where's the train?
But because I don't have anything to... Oh, God. I need coffee. Fuck off, train. So we've got our... Oh, God. Right. So we've got all our materials. Oh, my God.
This is going well.
TIG welding offers a lot more precision and a... Right. So now the other part's cooled down. To suit the M16 thread in the... Now I'm going to change out to an 8mm trill. Now I'm going to... Oh, wait, what? Help. Because I do have a spare Mugen shift knob. I do have spare Mugen. Pen.
Oh. Okay. Just redo that, please. Just open it wider.
I'm going to.
Whoa! Oh my god, it's still going.
So that's turned out really nice. Oh, fuck me. So that's turned out really nice, but I am going to set it up so I do a weld prep on the... That wasn't even a word. Right. So that's turned out really nice. I hear the word come out and I think it sounds bad.
It's not even coming out though.
It's dry. Oh, wait, I've already forgot what I said. So now we've got that done. There we go. Yeah, right. I fucking remembered. My brain went...